Hello, Haripriya.
Yes, sir.
Last class I gave you a question to solve. Did you solve it? Could you solve?
1 minute, I'll tell you this.
Do it now. Try now. Do you need help?
Sir, option C, 284 joules.
Option C, 284. Actually, it was very easy, na?
This direct substitution, sir.
Ah.
I took time for calculation.
Because delta W is not there because volume is constant. So work will not be there. PDV is the work. Volume is constant, so it will be 0. So delta Q is equal to your delta U. And what will be delta Q? It will be MC delta T. It's 0.08 into 0.17 kilocalorie, 10 power 3, 5. But you have to multiply calorie, na? With the calorie to is 4.18, you have to multiply for calorie to joule. And you'll get this answer, 284 joule. Easy question. Now see, these are the basic one, but before going to solve the difficult type of questions, all the better type of questions that they give usually, we need to study about few processes. There are few processes in thermodynamics on the basis of which the questions are being framed. What those processes are? One is isobaric process. Now, what is this isobaric process? Constant pressure. Second is isochoric. Constant volume. Third is isothermal. Constant temperature. Fourth is what? Fourth is what? Adiabatic. no heat exchange. Okay, these are the four processes that we need to study before we can actually jump into solving the difficult kinds of questions. Okay, now what is an isobaric process? Actually, see, Haripriya, we need to actually, whenever you will be solving questions on this, one equation that you will be making use of constantly is PV is equal to nRT. That's gas law. That applies for every ideal gas. It's ideal gas law. There are a few changes in real gas, but actually all the gases that we study here, they are actually, these all gases are actually ideal gases. They are treated to be ideal gases. Okay, that's the thing. Now that's one thing important. Now coming to isobaric process. In isobaric process, P is equal to constant. This is one thing. So one thing is for sure in this isobaric process, whenever P is constant, if we talk about PV is equal to nRT, N is what? Achha, do you know something about this? What is N? What is R? Haripriya, do you know this?
Yes, sir.
Yes, na? Where N represents the number of moles. R is the gas constant. This actually they should have taught you in your chemistry classes in properties of matter. T is temperature in Kelvin. P is pressure and V is volume. Now, when we are saying P is constant, let's say what things are constant? P is constant, N is constant, R is constant. Because N is number of moles. If we are not changing the number of moles in a gas, number of moles of a gas, we are not adding the number of moles. We are not adding some other gas to the existing gas. That means we are not tampering with the number of moles present already. So that means number of moles will be constant. Gas constant R, its value remains constant always. So when we set P is constant, so we can write V by T will be constant. So this is the law we can use when in an isobaric process, something is moving from point 1 to point 2, then we can say V1 by T1 is equal to V2 by T2 to find the unknown things. Okay, this is why I said this V by T is constant. Correct? Now coming to applying the isobaric process to first law of thermodynamics, delta Q is equal to delta U plus delta W. In an isobaric process, see, whatever in the beginning only I told you, whatever may be the process, the value of delta U does not change. It's because of it is in internal energy. Internal energy does not depend on the external factors. Its value remains constant, that is NCV delta T. Always. Remember, this will be same for all the processes. It does not change. Clear? Now, talking about delta W is what? It's PdV. Pressure into change in volume. Why we get PdV? Because see, if I show you, work done that we know of is force into displacement. But if I divide force per unit area and multiply area with this, I can write this as force per unit area is pressure. A dx is dV, change in volume. So like that we write delta W as PdV. Now, PdV is there. Using this equation PV is equal to nRT, I can write if P is constant, PdV is there, N and R are constant, I can write this as equal to nR delta T. or nRdt. Correct? So now this is the second thing that you must remember when you are calculating the work done. Now talking about delta Q, heat exchange in this process. This is delta U plus delta W. So I can write NCV delta T plus NR delta T. But I can write this as N into CV plus R into delta T. But since I know there is a relation Cp minus Cv is equal to R, that means Cv plus R will be Cp. So it will be N into Cp delta T. That's why in a isobaric process, the heat exchange is NCp delta T. Understood these things? See, you have to take
Yes.
care, Haripriya. This thing remains always same. Delta U always remains same. Whatever may be the process. This thing I'm telling you to both Kanishka and Haripriya. This delta U remains same for all the processes. Does not change. Only changes occur in delta W and delta Q, depending on the process. Now I'll ask you to draw some graph. You have to make use of this equation PV is equal to nRT to predict the graph. First, draw me PT graph. Then draw me PV graph and then VT graph. Tell me what should be the P versus T graph for a isobaric process. What happened? Not able to find. It's very easy. Array, see P is equal to constant na. When P is constant, meaning is what? Whatever may be the temperature you change, pressure is not going to change. Whatever temperature you change the process into, the pressure is not going to change. That's what P is equal to constant means. Whatever may happen, you may do anything in the process. You may change volume, you may change temperature, but pressure is not going to change. That means the graph will be a straight line for all the temperatures. It depends what the where it will be. It may be that the value will be P naught depending on what pressure the gas is kept. Similarly, the PV graph also will be like this only. constant value. Now tell me, do you have any doubt in this one? PV or PT graph?
No, sir. VT would be a straight line.
Straight line
Yeah, from origin.
passing through the horizon. Correct. But now one more question I have. If you say it is a straight line passing through the horizon, what will be its slope and tan theta value? Again, see, you can make use of that equation PV is equal to nRT. You can make use of it's a hint. Use PV is equal to nRT to find slope of V versus T graph for isobaric process.
NR by P.
NR by P. Because see, V is equal to NR by P into T is there. V is Y, T is X. It's like Y is equal to mx. So what will be slope? NR by P. Okay, simple. Now let's move on to the different process. Second process is what? Isochoric. Now you have to tell me what should be the different things for this. V is equal to constant. Now let's start with this. PV is equal to nRT. I can write here T by P is constant, right? Yes, na? So I can do
Yes,
T1
sir.
by P1 is equal to T2 by P2 for calculation. That's one thing. Let's keep it aside. Now, for delta Q is equal to delta U plus delta W, can you tell me what should be the work done?
There wouldn't delta Q be equal to delta U because delta V is equal to 0.
You should have given me the answer delta W is equal to 0.
Okay.
And you said delta Q is equal to delta U. But what will be the value of delta U? I just said in the previous process. Delta U
Yeah,
remains same.
NC V delta T.
Whatever may be the process, this value does not change.
So then for this process, CV would be equal to CP.
No, in this process, actually CP does not come into picture only. See, don't make that habit, delta T. Okay, only in that process, constant pressure process, delta Q is equal to NCP delta T we have got. But it's not necessary that in every process, if the volume in every process we'll be writing delta Q is equal to NC delta T. C becomes CV here, C becomes CP there. Okay. But what you told is correct. It's not wrong. Now quickly draw the graph. I'll give you 3 graphs. VT graph, VP graph. No, I'll draw PV graph because that's standard one. PV graph, and the third one is PT graph. Tell me, what should be the first graph?
They're parallel to x-axis.
Very good. First graph is correct. What will be PV graph?
Parallel to y-axis.
Very good. What will be PT graph?
A straight line passing from origin.
What will be the slope?
N R by B.
Because PV is equal to nRT is there. nR by V into T, Y is equal to mx. Very good. Let's move on to the third process then. Isothermal. Where is isothermal? After isothermal, we'll solve some questions. No, after adiabatic. Isothermal temperature is constant. The first thing first, PV is equal to nRT is there. T is constant, so in this you can do PV is constant. That means P1 V1 is equal to P2 V2. You can do first thing. Then now tell me, in the delta Q is equal to delta U plus delta W. Delta U will be NCV delta T, because that we know it remains same for all process. How you will find delta
But
W?
delta U would be 0 no, sir, for isothermal.
Correct. Because temperature is constant, delta T is 0. So it will be 0. Very good. Good. Now delta W, how will you find? It's PdV, but how will you find? I'm telling you have to find out the work done if the process is moving from volume V1 to volume V2. How will you find out the work done? Since delta U is 0, delta Q will be equal to delta W. But everything comes to finding out the value of delta W.
P into V2 minus V1.
Wrong. You cannot just take P constant, because P is not constant now. Let me show you. See, if I draw the PV graph of this, whenever you're changing volumes, see, you have calculated P into V2 minus V1, but that is only possible when pressure is constant. When you are moving from V1 to V2, pressure is also changing, na? It was here, pressure was P1, here pressure is P2. If pressure was constant, your answer was correct. P1 into V2 minus V1. P into V2 minus V1. But pressure is changing, how you will find out? Kanishka, do you have the answer? Through this, I have shown you the PV graph. It's rectangular hyperbola, you know? You know the xy is equal to c square. Xy is equal to constant is a rectangular hyperbola. That's why I have drawn PV is equal to constant rectangular hyperbola. Now tell me, do you have any clue how to find out the work done? No? See, what I will do, using this gas equation, I'll write this PdV as P as nRT by V. Okay. Now to find out the work done, I will have to integrate. Variable is dV. Volume is changing. So temperature is constant, nr is constant. So integral nRT dv by v, nRT will come outside. Understood? What I did, I made use of Vv is equal to nRT. I can, because pressure was also changing, dV is there, so I brought pressure in terms of volume V. Rest all things are constant, I can take them outside the integration. Then to find out the total work, I actually integrated. Integration means adding up all the work done in small intervals. Tell me, you understood or not?
Yes, sir.
This is how we calculate work done in the isothermal process. Now, once you have found out the work done, you can actually once you have found out the work done, you can actually write the value of delta Q also, because delta U is 0, delta by first law, delta Q is equal to delta W also. So delta W will be equal to your nRT, delta Q will be equal to nRT ln V2 by V1. ln is natural logarithm. Okay, C. Understood these three things? Now I have one question now. If I'm drawing such a graph, see, I have drawn the PV graph is like this. Rectangular hyperbola. Now, if I'm drawing the other hyperbola, and I say this has the temperature T1, this has the temperature T2. Now, can you say which is greater? T1 is greater than T2, or T2 is greater than T1? Which will be correct? Which is greater than what? Think and then give me the answer. No idea. Just give me your guess, Kanishka and Haripriya. See, actually, this is correct. Why? PV is equal to nRT is there, na? Take some pressure value. No, I'll take the bottom one below. Take some pressure value, some volume, V naught, P naught. At the same pressure, hmm, if I take the same pressure and same volume, if we take the same volume, the pressure has to be higher. That can only occur if I take the same volume. See, volume is same volume V naught, then P by T should be constant. So if for the same volume, for the blue graph, I'm getting the higher pressure. For the lower graph, I'm getting the lower pressure. So that means to make P by T constant for same volume, pressure, if pressure is higher, temperature has to be higher. So this is P2 at same volume. Since P2 is higher than P naught, P2 should be higher than P1. Got it? Understood? I'm fixing the volume. If I fix how do you analyze it? To analyze it properly, what you do, you just fix the volume at one place. See, at same volume, you are getting the two pressure values, one for the lower graph, one for the upper graph. And when we fix the volume, that means we have made volume constant. That means P by T should be equal to constant. So if on a graph, the pressure is higher, to make P by T constant, temperature has to be higher. So the higher temperature graph would correspond to the graph in which for the same volume we are getting the pressure higher. Correct? This is how we see. Okay, Priya? Haripriya, Kanishka, are you able to understand or not? Is it difficult? You guys keep silent actually. After this, draw me this graph. PV graph you already know. TV graph we already know. TV graph you have to draw. And one more PT graph you have to draw. Do it quickly. Then we'll give you some questions to solve. Haripriya, tell me quickly. What should be TV graph? I feel that you're sleeping. Get slept off. Haripriya, wake up. Are you there? Kanishka? That's the problem with keeping class late. I'm not able to hear.
Sir, could you repeat your questions?
Where were you? You slept?
At dust.
I know. It's Kanishka is already sleeping.
Sir, it's too late. Sir, like 10 to 11.
Because see, Kanishka has actually other classes, na? Because of her only we are. I have to keep it late. And also this Diva, today she said to me, sir, I have practical tomorrow, but the problem with her is on this day she comes late from her coaching. It's nearly 9. So then the earliest I can keep is 9. But 9 is she is not comfortable, Tanishka. And when I keep at 10, she's sleeping, not giving answers. And when I keep the class early, she'll say that I'm losing the class. Hmm. Try to solve this question. Hmm. Try solving this.
25 seconds.
25. D
2 point.
or
Yeah.
option D? Wait, let me check. Hmm, where is it gone? Hmm. No, they're saying it's 2.5 into 10 power 2. It's not 25. Let me solve and then check. Electrical appliance applies 6000 joule per minute. Delta Q is equal to delta U plus delta W per minute. Heat is given, so per second 6000 by 60. Delta U. Achha, how long will it take? Achha, we are actually doing everything in power. System delivers a power of 90 watt. So we are actually dealing with powers. So this is 90 watt. How long will it take to increase internal energy by 2.5 into 10 power 3? So 2.5 into 10 power 3. We can divide by time t. The time we need. And this is the answer. Easy question it was actually. Do another one. They're actually easy questions, not tough one.
Sir, 500 R.
Correct. Very good. Try solving this question. Do it quickly, then I'll end the class. Then in the next class, we'll study about the adiabatic process.
Sir, 5.
25 they're saying. Or let me solve it quickly. See, rigid diatomic gas is there. Delta Q is equal to delta U plus delta W is there. Work is Q by 5. So delta Q is equal to delta U plus Q by 5 is there. Q is supplied, means Q is equal to delta U plus Q by 5. So delta U we are getting is Q minus Q by 5. 4Q by 5. So it is 5 by 4. Delta U means NCV delta T. Q I can write for any process NC delta T. And delta T I'll cancel. Q is 5 by 4 CV. And diatomic gas is there. For diatomic gas, 3R by 2, 5R by 2. 5R by 2 is a CV. $25 by 8 into R. So the value of X is 25. Okay, this is the answer. Check your calculation where you have done wrong. Okay, let's end the class then.
Good night, sir. Bye, sir.
Good night.